Welcome again, Wildcats. So today we're looking at Wednesday, November 9th, radical expressions and rational exponents. And that's going to be on page 31. So if you would, pause and update your table of contents. All right. So for today's lesson, you're going to need a pencil, tissue box, okay, and an eraser, because this assignment is going to be very difficult. So it could frustrate you, could make some tears, okay? So tissue box, have that available, okay? All right, so let's look at our notes on page 31. All right, so we have the properties of nth roots, and this applies when a is greater than 0 and b is greater than 0. So the product property of roots. So if we had the cube root of a, b, that's equivalent to the cube root of a times the cube root of b. Okay? The quotient property of roots. Okay? So if you had the cube root of a divided by b is equal to the cube root of a divided by the cube root of b. And I think I'm going to go ahead and actually change this so it fits more general to the nth root. Okay? Because n the value doesn't have to be 3. So I'm going to make this the nth root. Okay? So the quotient property of roots, if you have the nth root of a divided b, that's equivalent to the nth root of a divided by the nth root of b. All right, let's look at the rational exponents. The exponent 1 divided by n indicates the nth root. So you have a to the 1/nth is equal to the nth root of a to the first power. The exponent m divided by n indicates the nth root raised to the mth power. So you have a to the m divided by n is equal to the nth root of a to the mth power. Properties of rational exponents. So the product of powers property. So if you have a to the mth power times a to the nth power is equal to a to the mth plus n. The quotient of powers property, if you have a to the mth power divided by a to the nth power, that's equivalent to a to the m minus nth power. All right, you have the power of a power property. That's a tongue twister for you. So if you have a to the mth power to the nth power, that's equivalent to a to the mth times nth power. And then the power of product property. So if you have ab to the nth power, that's equivalent to a to the nth power times b to the nth power. And then you have the power of a quotient property. So if you have a divided by b to the nth power, that's equivalent to a to the mth divided by b to the nth power. All right, so if you would take some time to update your notes. All right, now that your notes are updated, let's take a look at the examples. All right, so example number 1. All right, so it says, simplify each expression and assume that all variables are positive. Okay, so we're using the, let me find the property here to make sure I say this. We're using the, make sure I find the right property. The product property of roots, because we have the product here. So that we know that we can write this as the cube root of 27 times the cube root of x to the 6th power. Okay, so we know the cube root of 27 is 3, because 3 cubed is 27. So 3 times 3 is 9, 9 times 3 is 27. Okay, times the cube root of x to the 6th power is x squared. All right, let's look now at example 4. All right, so we're using the quotient property of roots, and we know that we can write this as the fourth root of x to the eighth divided by the fourth root of x to the, or fourth root of 3, sorry. All right, so we know that the fourth root of x to the eighth is x squared, and this is just the fourth root of q. But it says to simplify, okay, and I think my head probably just cut off this, so let me go back over this. We're using the quotient power of roots, so we know that we can write this as the fourth root of x to the eighth divided by fourth root of 3. We know the fourth root of x to the eighth is x squared, and the fourth root of 3 is just the fourth root of 3. But when you're simplifying, you can't have a radical in the denominator. So what we need to do is multiply I'm going to explain this here in a minute. Actually, probably about. Let me get a ruler to straighten that out a little bit. All right, and the reason, first off, I want to make sure you understand that I've manipulated this problem mathematically. But first of all, anything divided by itself is 1, anything divided by itself is 1, anything divided by itself is 1. So I haven't changed it, but what I have done is I've manipulated the denominator to get rid of the radical, okay? So this is equal to x squared times the fourth root of, now we know because of the property, let's see, which property are we using here? The property of roots, that we can rewrite this as 3 times 3 times 3 divided by the fourth root, and we're doing this because of the product property of roots, can be written as 3 times 3 times 3 times 3. Well, this becomes x squared root of 9. And I'm going to put this in the calculator to show you what happens. So, all right. So if I do control the fourth root of 3 times 3 times 3 times 3, you'll see that the fourth root of 3 times 3 times 3 times 3 is 3. So this is now simplified. Now, if you're kind of blinking your eyes, and you're nodding your head like, what in the world's going on? I'm going to go over example 3 in class, and example 3 is similar to example 4. So hopefully you can ask questions in example 3, and I'll go over example 4 again if you like. Okay. All right. So now let's look at example 5. All right. So we're using the product property of roots to rewrite this as the cube root of x to the 7th times x squared. Now we're going to use the exponent rule of, product of powers property that says when you multiply these, you add the exponent. So this becomes x to the 7th plus 2, which is the cube root of x to the 9th, which equals x to the 3rd power. And you're probably wondering what just happened to get there. Well, we can use the exponent m. We can use this note right here, is what I just used. Okay, so I can rewrite that as x 9 divided by 3, which is why it's x to the 3rd power. All right, so now let's look, and I almost forgot, this is page 31. So now let's look at all right. Now this video is going to go a little longer just because I want to go over more examples in it. All right, it says write an expression in radical form and simplify. So to convert this to radical form, using, make sure I give you the right property here. I'm using this property right here. So look where the m goes, look for the n, okay? So this can be rewritten as the cube root of negative 125 squared. Which is the cube root. So at this point, you want to put negative 125 in your calculator squared. Make sure that you use parentheses because any number squared is positive. So negative 125 squared is 15,625. And then you just use a calculator to do the cube root of 15,625. Now, I'm working it out to get to the number. What you might do in this video is you might get to here, and then in class ask me, Mr. Luke, how do you put this in the calculator, okay? So again, work up to here, write this down, and then wait, and then you can ask me how I put that in the calculator. All right, so let's look at example 9. All right, now example 9 says write expressions by using rational exponents. Okay, so to do example 9, again, we're using this rule, except we're going backwards. So we're going from this to this, okay? So we know that that's equal to 7 raised to the 3/4. All right, let's look at example number 12. All right, now example number 12, we're using, I'm going to make sure I say this right. This property right here. We're using the product of powers property. So when you multiply, you add the exponents. Okay, so this is equal to 36 raised to the 3/8 plus 1/8, which is equal to 36 raised to the 4/8 which we know that becomes 36 to the 1/2. And we can basically, again, using this, we can go from here to here. So this becomes the square root of 36 to the 1 power, which we know the square root of 36 is 6. All right, and then let's go over one more example. Let's go over example number 13. All right, so we're using the, and I want to make sure I say this one right. We're using the quotient of powers properties. So we're going to go from here to here, okay? So that is equal to 8 to the 1/3 power minus 2/3, which is equal to 8 to the negative 1/3 power which is written as, make sure I say this right. Whenever you have a negative exponent, it becomes positive in the denominator. So this is rewritten as 1 divided by 8 to the 1/3. Okay? Which becomes 1 cube root of 8 Now, when you simplify, you can never have a radical in the denominator. So we're going to multiply this by the cube root of 8. By the cube root of 8. Now remember, all I'm doing is multiplying by 1. Okay, I'm manipulating it to do this. Cube root of 8 divided by cube root of 8. And I did that because this is going to become 8. And I'll show you that in the calculator in a sec. So this becomes equal to the cube root of 8 times 8 divided by the cube root of 8 times 8 times 8. So this becomes the cube root of 64 divided by, and I'll use a calculator here. So control, top. And to get that power, basically, what I'm doing is pressing control, this button right here. All right, so that's the cube root of 8 times 8 times 8, which you'll see is 8. Which is simplified. Okay, hopefully you've enjoyed this radical Wildcat adventure, and I will be in class tomorrow with some radical explanations of these radical expressions. So have a terrific radical Wildcat day.